Hi, I'm Lydia,
And I'm Haley.
and today we're going to be reporting to you on intertidal zones. The intertidal zone, also called the littoral zone, is where the land and sea meet between the high and low tide zones. This complex marine ecosystem is found along coastlines worldwide. It is rich in nutrients and oxygen and is home to a variety of organisms.
Today we're going to talk about 10 intertidal organisms. The 10 we're going to talk about are barnacles, hermit crabs, mussels, sea stars, limpets, sea anemones, sculpins, isopods, chitons, and ghost shrimps. The first organism we're going to talk about are barnacles. You can find barnacles on almost any solid surface that gets covered by water, like rocks, dock pilings, boats, and even mussels. After selecting a spot, the barnacle secures itself head first to the surface with a strong brown glue. Once it's secured, the larva grows into an adult and builds a tough housing. The barnacle secretes the calcium-hard plates which totally encase it. These white cones have 6 nearly fitted plates that form a circle around the crustacean. 4 more plates form a door which the barnacle can open or close depending on the tide. When the tide goes out, the barnacle closes the doors to conserve moisture. And as the tide comes in, the barnacle opens up these 4 plates, and the feathery legs of the barnacle sift the water for food. All 6 pairs of these feather-like feeding appendages, called cirri, are jointed and set with sensory hairs which brush the water, collecting plankton for the barnacle to eat. These legs also have gills for gas exchange.
Next we have mussels. Mussels attach themselves to rocks and form colonies called mussel beds. In order to deal with the pounding waves, temperature, streams, and air exposure that come with living in the intertidal zone, mussels have developed hard shells and viscous threads to protect themselves. Viscous threads are tough hairs mussels use to stay attached to rocks. While mussel beds can withstand the changing tides, global climate change may cause damage to these diverse ecosystems. As the amount of carbon dioxide in the air increases, so does the amount of carbon dioxide dissolved in seawater. The resulting acidification changes the basic chemistry of the oceans and decreases the growth rate of organisms which rely on dissolved calcium carbonate to build their shells. If current carbon dioxide emission trends continue, it is possible that mussels will remain smaller for longer periods of time and be less able to protect associated epiphauna, organisms which live among the mussels, from temperature extremes, which may also increase due to global change. Their main predators are birds, crabs, and snails. They eat by filter feeding through the water to get plankton and other small organisms.
Here's a picture of a mussel. Woo! The next organism are limpets. Limpets eat by moving over the rock surface, grazing on young seaweeds with a radula like a periwinkle snail. The limpets have a tough radula designed to excavate and shovel the algae into their mouths. Limpets make their home in rocks. On soft rocks, the abrasion between the limpet shell and the rock results in the formation of a shallow depression or home scar in the rock surface. On hard rock, the shell will be worn down to make it fit perfectly into the rock. The limpet clamps the rock tightly with its large foot, trapping water under the shell, creating a moist environment under its shell that allows the limpet to breathe and not dry out while exposed to the air. Limpets prefer to settle and feed on coralline crust algae. This animal and algae have a special relationship called mutualism. The limpet gets a constant source of food and a smooth surface to feed from, while the algae benefits by having its surface cleaned by the limpet. Without the limpet, crust on the algae would suffocate under the debris, and faster growing algae would overtake its space. Here is a picture of a limpet. Ooh, limpet.
The next organism we have, the intertidal zone, are hermit crabs. There are about 500 different types of hermit crabs in the world. Hermit crabs are mainly scavengers and can often be seen digging for food, preying on smaller organisms, or scrounging for scraps on the ocean floor. They eat worms and ocean debris. Hermit crabs carry their shell homes on their backs and tuck themselves away inside for protection using their strong stomach muscles. They use their large right claw for protection and holding food, and a small left claw for eating. Hermit crabs only leave their shell to search for new ones, and the fewer empty shells available in the intertidal zone, the more difficult crabs have to find a home. Hermit crabs must deal with being in and out of the water, large exposure to the sun, and varying climate changes. Due to their small size, hermit crabs have numerous natural predators all around the world, which include sharks, cuttlefish, squid, and octopi. It is thought that the hermit crabs often hide amongst other animals such as sea anemone as a form of natural protection.
Here is a picture of a hermit crab. Oh, so cute. The next organism are sea anemones. Sea anemones are stinging polyps that spend most of their time attached to rocks on the sea bottom or on coral reefs waiting for fish to pass close enough to get ensnared in their venom-filled tentacles. Their bodies are composed of an adhesive petal disc, or a foot, a cylindrical body, and an array of tentacles surrounding a central mouth. The tentacles are triggered by the slightest touch, firing a harpoon-like filament into their victim and injecting a paralyzing neurotoxin. The helpless prey is then guided into the mouth by the tentacles. The sea anemone survive the onslaught of the intertidal zone by literally going with the flow. The simple tissues respond to the impacts of the ocean with ease. For the sea anemone, the main threat doesn't come from being battered to pieces, but from drying out and being eaten, of course. They combat these issues by folding in on themselves, thereby reducing their surface area and opportunity to lose water. The anemones can also be quite adept at cloning themselves. If the threat of being gobbled up is high, it is certainly advantageous to make more than one copy of yourself. In some parts of the intertidal zone, you can find whole rocks simply covered with sea anemones that are all clones of one individual. Their most dangerous predator is called a nudibranch, a type of sea slug. The nudibranches can eat the arms of an anemone clean off. Wowza! Wow. Now, here is a picture of a sea anemone. It's so pretty and colorful. Woo! Look at those colors.
Next, we have sea stars. There are some 2,000 species of sea stars living in all the world's oceans, from tropical habitats to the cold sea floor. They have bony, calcified skin which protects them from most predators, and many wear striking colors that camouflage them or scare off potential attackers. Sea stars are famous for the ability to regenerate limbs, and in some cases, entire bodies. Starfish are sensitive to marine pollution and changing water temperatures, which is common in the intertidal zone. Starfish may be preyed on by starfish species, tritons, crabs, fish, seagulls, and sea otters. Some species excrete a toxic mucus to defend against prey. Their spikes and rough textures turn away predators as well. And now we have a picture of a sea star. A picture of a sea star.
Look at the beautiful sea star. Really captivating.
Lovely.
Now we have the ghost shrimp. Ghost shrimps are residents of intertidal zones and bay flats on the west coast of North America. They like to burrow in seafloor sediments. These burrows protect the shrimp's soft white bodies, but more importantly, as the shrimp wriggle along, they collect food from the sediments and from the water flowing through the burrows. They are very hardy animals, and the ghost shrimp can survive without oxygen for as long as 6 days. Wow. To find enough food.
Wow.
It's really interesting. To find enough food, ghost shrimp tunnel almost constantly, reworking the sediment to a depth as much as 30 inches. Their burrows are attractive to other small invertebrates as well, both for protection from predators and for leftover food. Other inhabitants of a ghost shrimp's burrow might include pea crabs, scale worms, and snapping shrimp. A clam might even put its siphon into a shrimp's burrow. Ghost shrimp's main predators are humans because fishermen use them as bait. Bad fishermen.
And now we have a picture of a ghost shrimp for you guys.
There it is. They're clear.
The next organism we have are sculpins. There are about 300 species of sculpins. All sculpins look very similar to one another, though distinct from other tide pool creatures. They have long, thin bodies with big heads and stripes, about 5, all the way down the length of their bodies. Sculpins are able to find their way back to their favorite tide pool, following a high tide. Sculpins eat small invertebrates, isopods, amphipods, shrimp, and worms. They can change the coloring of their bodies to blend with their surroundings, allowing them to ambush their prey. Their predators. Tide pool sculpins have a number of predators. Common predators of the sculpins include large fish, crabs, shore birds. Luckily for them, they were graced with speed and the ability to blend and hide, allowing them to protect themselves from creatures who would like to eat them.
Here we have a picture of the amazing sculpin. A good-looking fish. Continuing on our journey through the life of the intertidal organism, next we have isopods. Common west coast species of shore-dwelling isopods are found among seaweed and seagrasses, under rocks, in wood, and in rock crevices. Isopods are omnivores or scavengers, feeding on dead or decaying plants or animals. Some may eat live plants. Isopods breathe with gills, so they are restricted to areas with high humidity, like under rocks or logs, in leaf litter, or in other crevices. Some species are also nocturnal. Isopods have hook-like appendages that help them attach to kelp. Here is a picture of the isopod. They look very similar to what we know as pill bugs.
The last organism we have for you are chitons. About 800 existing species of chitons are identified. All are rock-dwelling marine mollusks with oval-shaped bodies that are flattened from back to front. On a chiton's back are various calcium carbonate shell plates that overlap, which provide protection from above but still allow them to curl up into a ball if they are lifted. They live on hard surfaces such as or under rocks or hidden in rock crevices. Some species live quite high in the intertidal zone and are exposed to air and sunlight for many hours each day. They become active at twilight and move around very slowly in search of food. They can feed on small algae, small crustaceans, and other tiny organisms. Some chitons exhibit homing behavior, returning to the same spot for the daylight hour and moving during the night to feed. Animals which prey on chitons include humans, seagulls, sea stars, crabs, lobsters, and fish. And we have a picture of a chiton for you. Can you see how their shells overlap in the back?
Snazzy.
As a coastal habitat, the intertidal zone endures a variety of negative human impacts. The greatest impact can often be seen and felt through the loss of algae as they are treated upon and worn away, resulting in a loss of habitat. Many tourists take organisms such as crabs back home with them. Although tempting, these organisms cannot survive away from their habitat. Urban runoff is pollution that is washed by rain, sprinklers, and any running water from our yards, streets, and other urban spaces into nearby waterways and eventually into the ocean. Often, when the runoff gets to the ocean, it goes right through the intertidal zone at its highest concentration before it disperses offshore. The pollution that gets washed away includes pesticides, herbicides, and fertilizer from our lawn, car fluids from roads and driveways, pet waste, and general litter.
Don't do this. You
Do
shouldn't
not
take this from the beach.
No.
Bad.
What we can do.
What we can do to help these organisms is become more aware of how these organisms survive and be aware of their needs when visiting the intertidal zone. Don't take them. Don't do it.
We just want to thank you guys for listening to our Intertidal Zone podcast, and we hope you learned something.
Yeah, chitin. Did we say chitin or did we say chitin?
Haley.